And so from this, we can actually see that we have a gizmo, sorry, a gizmo. We have a function that has y is equal to c times 1 plus r to the third power, or to the t power. And we have y is equal to 1 plus 0.2 raised to the t power, okay? So here, what we can do is we can change c and we can change r to different things. Now, does anybody know why we would want to use this particular formula right here? Has anyone ever seen it before? Okay, okay. This is called the interest formula. Who knows what interest is?
It's money you gain over time or lose when you or you deposit cash in a bank account.
I equals PRT.
Caleb, we're not making a bank account. Stop being an accountant.
So, yes. You guys are right. Sorry, I blanked for a second. So yeah, you guys are right. At least partially right. So Caleb, one thing about interest is that you actually never lose money. An account is always gonna gain money with interest. And the reason for that is because the account could be a loan that you have to pay back. So yeah, I guess in a sense you are losing that amount of money because you're owing it. But the account itself is always going to gain money. And yes, Aoife, you were right. You said I equals PRT, which is basically what we have here. P stands for principal amount. R stands for your rate. And T stands for terms, or sometimes people say that it stands for time. Either one is fine, really. And then I is going to stand for interest. So here we have something a little bit different because we have 1 plus R. So this is asking more or less how much is going to be the total amount owed, or the total amount in my account. In other words, we add that 1 so that we have, let's say my interest is in this case 2, right? That way we can have, or actually I think this would be like 20%. So if this was like 20%, then it'd be 120% that we are gaining every time. So growth and decay. This is a graph that's basically going to show you whether something is going to be growing or something is going to be decaying. And there's a couple of different things that can both grow and decay. So can anybody think of something, of an exponential function that's going to grow? Something that uses exponential functions that's going to grow over time.
I don't get the question.
Okay, that's fine. So let's think about in the real world, Liz. Exponential functions are actually very, very heavily used, and that's because exponentials growth and decay are basically found throughout the world. So, for example, an exponential growth example can be money. So, money, specifically with interest. That is a point in time where sorry. Sorry. this is an example that we have in the real world of what we see when something is growing exponentially, right? So you have money and you're growing it with interest, and it's getting bigger and bigger over time. So whether this is a money in your bank account or a loan, that is an example of exponential growth. Another example of exponential growth is infections. So when something is infected, right, or there's like an infectious disease going around, it's actually going to grow exponentially, because one person will affect two people, and those two people will affect another two people, and so on and so forth, and that grows.
Like this whole thing with the pandemic. Okay, that's a bad example. Ignore what I said.
No, you're exactly right, Daniel. This pandemic is actually growing at an exponential rate. And I know it sounds kind of scary, but it's good for us to basically understand what's going on.
I'm
Right?
actually not scared of this whole thing.
Well then that's good, Daniel. Just, as long as you're staying safe. So these are things that grow exponentially because they're basically like doubling, Another one is population growth. So for example, let's think about like my dogs. Okay. So let's say
Wait, sir, how are the puppies?
the puppies are good, actually.
Yeah.
Now this is actually one of the reasons that there's so many stray dogs and dogs without a home is because well, let's think about what would happen, or let's think about how many puppies a dog has. Do y'all know how many puppies a dog litter has? About how many?
I think
How
8.
many?
So we can estimate around 7, 8 to 10 puppies per litter, right? So we have two dogs, right? Boy dog and a girl dog, and they make 10 doggies. What's gonna happen if every two dogs made 10 puppies, right? And then each of those puppies basically made another 10 puppies, and then they made another 10 puppies, and then they made another 10 puppies. How many puppies are we going to have by the time that, that like 4 generations have gone on? It's
A lot.
Yeah, it's going
The
to be a
day
lot.
when dogs take over humanity.
Exactly. And so that's another example of population growth, and that actually happens with humans as well. So if a human has not necessarily like we make more humans, but let's say we're moving to a city, okay? And so if we have a small city, and then let's say we build a factory, and there's more people going in there, and there's more jobs, then more people start moving to the city, and if more people move to the city, then we need more jobs, and so more people move in, and more people move in, and more people move in, and the city starts to grow and grow and grow and grow. And that's how we get big cities like Houston, like Austin, like San Antonio, like Dallas, because the population of that city is growing at an exponential rate.
And one of the most dangerous places in the United States.
Not necessarily, but I guess you could say that.
No, with the pandemic thing. It's one of the most dangerous.
Oh, I see what you're saying. Yes, exactly, Daniel.
Okay, why did I bring that up again?
Don't worry. Anyway, let's talk about decay for a second. Now, can anybody think of an example of exponential decay?
An apple when they die.
An apple when they die. Can you explain?
Like a rotten apple.
That's just regular decay, like biological decay.
Never mind.
So
never mind then.
you're actually kind of right. So rotting will actually do it in an exponential way, because it starts off with a little bit, right? And as soon as a little bit gets infected, it will start to get more and more rotted. The problem with rotting is that it is actually an exponential function in the growth because the rot is growing. Does that make sense? So it's not really decaying. But what I just looked up, which is radioactive decay. Is actually a form of decay that actually does happen. So when you have radioactive decay, you basically have a material, doesn't really matter what, an element. And what happens is, like, if you leave it out for a while, and I'm talking about like years in most cases, when you come back to it, you're actually going to have a bit less.
The Antarctica.
So it's going to go from a lot to a little less. And this is called radioactive decay. And it is something that you guys are going to explore in chemistry.
Isn't that the similar thing with Antarctica? Sorry.
Yeah, actually, Daniel, you're right. Like when you're talking about how it's shrinking.
Yes, nothing.
Yeah,
Okay,
that's decay as well.
Okay, sorry for making all of you penguin and polar bear lovers sad.
Not a problem, Daniel. All right, so now going back to this, we have exponential growth and exponential decay. And we can move C to be either more or less. This is going to be what we call our what? Does anybody remember what we call C?
Our y-intercept?
It's our y-intercept if it's not transformed, but we remember we have two keywords. We have either the initial, we have either the initial value or we have the base. So which one is C, initial value or base?
Initial value.
Initial.
That's the initial value, that's correct. So I can go ahead and add that in there, right? And then my base is going to be this right here, the 1 plus whatever my rate is, okay? Now, let's look at the questions and see what they're actually asking. Okay, it says, which of the following is false for an exponential growth function y is equal to c times 1 plus r to the t? Okay, so we're looking for something that's false. And let's read this out. When c is greater than 0, the function decreases from left to right. Okay, let's see. So if c is greater than 0, the function decreases. Is it decreasing, guys?
Yes.
When c is greater than 0?
Oh, no, no.
Right. When is it decreasing, Caleb?
When it's under 0.
Yeah, when it's under 0. So
like
is
Caleb said.
Now,
Sorry, Caleb. I had to make that joke.
I didn't even hear you.
Oh,
It's
okay, never
fine.
mind.
Now, here's the other thing. We can make our C bigger, right? And this graph is still decreasing. Why is this graph decreasing?
Because the R is a negative.
Yeah, because the R is a negative now. So in either case, this answer would be wrong because it doesn't necessarily happen all the time. So it's not always going to be false. All right. So the function has a y-intercept of 0, c. Let's see if that's true. Whatever my c is that always going to be the y-intercept for this particular function?
No.
Why not, Caleb?
Because C is just gonna be where oh no, C will be.
Yeah, in this case it will be, right?
Sir's doing an example. He was showing it. He was showing your answer.
Huh?
you were showing us the answer of your question when you were moving the gizmo.
What do you mean?
Like when you were messing around with the gizmo, you're basically answering the question.
Yeah, I
That's
was.
what he's supposed to do.
So this question, B, is gonna be true. And remember, we're looking for a false. We're looking for a false statement. All right. So B is true. So B is not going to be the answer. A is still a possibility, but it's not always false and it's not always true. So we're going to leave that one for the end. Let's see. The graph of this function will be identical to the graph of y is equal to a times b to the x if a is equal to c and b is equal to 1 plus r. Is that true, guys? Let's look at this. Y is equal to a times b to the x is equal to y is equal to c times 1 plus r to the t power if a is equal to c and b is equal to 1 plus r. Would these two be equivalent? Maddie, what do you think?
Yeah.
Yeah, they look pretty equivalent, right? So we
Yeah.
could say that this is a possible answer. I don't really like this question or this answer because technically they're not equivalent, because if you guys notice, this one has an x and this one has a t. So technically they're not equivalent, and I don't think that's the answer that they're looking for. So let's move on. If c is greater than 0 and r is greater than 0, then the graph will only have a positive y value. Okay, let's see. So if c is greater than 0, like let's say 1, and r is greater than 0, then my graph will only have a positive y value. Is that true, guys? Is there any way that I can make this have a negative y value by moving around my r or moving around my c?
Why
No.
value?
Sorry?
Never mind, sir.
Yeah, it's just that I can't hear you guys very well sometimes. But anyway, so C, we said that it's true, right? And D, we just proved that it is also true. So then the answer, the one that must be false, is going to be A. All right. And let's go ahead and see the explanation. So the correct answer for this one's going to be A, because when C is greater than 0, the graph decreases from left to right. It is false that the function blah blah decreases from left to right when C is 0. It's an exponential growth function, and the value of this will have an increasing y value and the x values. Okay.
So it can't go to the left at all. So it just stays to the right.
It can go to the. No, it is going to the left, Daniel. The thing is that they're saying that whenever this is like this, unless this is in the negatives, it's basically it was saying that this is always going to be increasing from left to right, but that's not necessarily true, right? Because it can decrease from left to right, right? So basically this was saying that it's always going to decrease. Do you see what it's saying? And like while here it's decreasing, if I move this over here, then it's increasing. Does that make sense? So that's not the answer. That's false because it doesn't always happen. Does that make sense?
Yes, sir.
Okay. Now let's see. What is the annual compound interest rate for an investment account modeled by the function 12 times 1.18 to the t power? Now, this is asking what is the interest rate of 1.18t. So let's talk about interest rates, okay? Because I told you that this right here your P times 1 plus R to the t power is equal to your interest formula. Okay. Now here, if we have 1 plus 1.18, what is the percentage that this went up, guys?
That'll be
In other words, what is 0.18 in percent form? This is decimal form. What
That's
is 0.1?
18%.
This is 18% because you move the decimal over twice. So the answer is going to be 18 right here.
that's simple.
Yeah, that's your explanation. The correct answer should be C, 18%, because 0.18 is equal to 18%. There we go, easy peasy. All right, it says, how much money will be in the bank account after 3 years if $4 is deposited at an interest rate of 5%? Okay, oops. So here's where we actually start to use our formula. So once again, we have, I like to use the formula F is equal to P times 1 plus R raised to the t power. And the reason for that is because F stands for future value. Sometimes I call this FV. P stands for principal. What does principal mean?
Like a concept?
Yeah, like if you guys know Spanish, do you guys know what principio means?
Like principal?
Yeah, it means the money you start with. Principal means the money you start with, okay? R is going to be your interest rate, and T is going to be your time, okay? So it says, how much money will be in a bank account after 3 years if $4 is deposited at an interest rate of 5%? So we're looking for my future value. I'm looking for my FV, right? And my principal, guys, how much did I start with? What's the money that I started with?
$4.
$4.
$4. Now, what is my interest rate going to be?
5%.
Yes, exactly. But there's something that we need to know about this interest rate. And this is super important, that the interest rate, whenever you put it into the formula, it must be in decimal form. Oops. So it has to be in decimal form. So can I put 5% there?
No, it's 0.05.
0.05. Good job. So it's 1 plus 0.05 raised to the t power. How much time are we doing this for?
3 years.
So 3 years. Okay. So actually, I can do this on my formula, on this graph right here. My C is going to be my initial value, which is going to be 4. My R is going to be 0.05. And look at what we have. We can actually show a probe, right? And so if I move this so that my T is at 3 years, do you guys see that? My time is at 3 years. I can move this to whatever time I want. But after 3 years, what's going to be my formula, ladies and gentlemen?
It'd be
4.63.
4.63. So then that's going to be my answer right here, which is going to be answer choice B. Do you guys see that? And again, the reason for that is because if we type in our formula, just like we have it over here, then we can go ahead and plug it into a calculator, whether it's a graphing one or a regular calculator, and it's going to go ahead and spit out this answer. Let's go to question number 4. Which of the following equations represent an account that will double after approximately 6 years? Okay. So, ladies and gentlemen, which one of these do you guys think is going to double after 6 years? Or at least, let's see. How would we know if this account doubled or not? Daniel, for number A, what should my account be at if it actually doubled?
Wouldn't that be 2 times like 2?
So what should my y equal for letter A?
Your y equals for letter A.
My y should be 2, because this number right here is my initial amount. It is my principal amount, right? So that has to double. So for A, y should be equal to 2. For B, what should my y equal, guys?
1.
It should be 4, because we're taking this initial amount right here. Do you guys see this right here? And we're doubling it. We're trying to get it to double. For C, what should it be?
4.
Ruben, what should it be for C?
Good question. I don't know.
Once again, guys, look. What we're doing is we are taking this right here, this number right here. That's my initial amount. That's my start. That's my principal. So if I want that to double, what should it be? 8.
8. Yep.
Because 4 times 2 is 8. And then for D,
16.
No, it'd just be 6.
it would just be 6. Because 3 times 2 is 8. So for D, y should be equal to 6.
I thought we were multiplying all of this by 2's.
You are, Daniel. What's 3 times 2?
No, I meant like from A 2 times
No.
equals 4.
These are each individual numbers. Don't get them confused, okay?
Yeah, I'm just a bit tired.
No worries. I understand.
I woke up at 7.
Oh, my bad. Okay. All right. So out of all these guys, which one do you guys think is going to double after 6 years? Well, we can actually plug them in one by one. If we go back to our graph, right? The first one we have is y is equal to 1. This one is equal to 1 plus 50, right? And we want to know what happens at 6 years. Okay. Did this double after 6 years, ladies and gentlemen?
Was
No.
No. It basically got 10 times as big, right? Almost. Or 11 times as big. So that one's not going to be it. That one's too big. Let's try this one. 2 is my initial, and 0.17 is my rate. So 2 for my initial, we'll plug that in there, 2, and then 0.17. Did that double?
No.
No.
No, remember, we're looking for the number 4. So that one's not it either. Let's try the next one. 4 and then 0.06.
Right then.
Okay, did that one double?
No.
No,
No, it didn't. We're looking for 8.
so it'd be D.
So let's see this one. 3 and 0.12. Let's see. 3 and 0.12. Okay, did that one double?
Yes.
Not
Well,
exactly, but it's so close that that's going to be our answer, okay? Because
Also
remember,
sure. Also sure. It showed the answer when you're moving down.
yeah, I
It
know.
showed.
I know, Daniel, but I'm showing you guys how to do this by actually solving it. And remember, it says which of the counts will double after approximately 6 years, okay? So it doesn't have to be 100% the correct answer. It just got to be the one that gets the closest to. So the correct answer is going to be D. Okay. And now number 5. Which graph could represent the function 0.97, 1 minus 0.24 to the t power? Okay.
Don't we write that down on the graph?
Yeah,
Like write that
Just
down on the
move
gizmo,
to the graph.
and it'll just give
exactly.
us the answer immediately.
So 0.97, and then what was the other value, Daniel?
Wait, sir. You forgot the decimal. It's just you wrote down 97.
Oh, that's my bad. Oh, it's not letting me. 0.97. Okay, it's not letting me do decimals for C. That's funny. It's only letting me do whole numbers, but that's okay.
Why don't we just put down 1 as this replacement?
We can do that. All right. And because 1 is pretty close, all right? And then it's gonna say minus
1.24.
negative
I'm at
0.24.
yeah, 24.
Okay. So this is kind of what my graph is gonna look like, right? And if we move this to and if we were to move this to 0.97, I guess it would be a little bit lower than that. But we can kind of get a good idea of what the graph is going to look like. So which one is the only one that goes down like that?
It's B by
B.
default.
Yes, the answer is going to be B, right?
Yeah,
Because that's
we
the one that looks
smart.
closest to. Now, if you guys weren't 100% sure, you could actually go to Desmos and type it in exactly. Y is equal
that's
to
what I did. Yeah, that's what I did,
0.97.
sir.
Good job, Daniel. Times 1 minus 0.24, all raised to the x power. And there we go. We see that it still looks basically the same. And so there you go. Those would be the answers, and that's how you would do that. I'm going to go ahead and ask you guys to do it on your own. I'm going to assign it to you guys, and then I'm going to post a video later on today. I'm going to expect you guys to watch that. And that's pretty much it.